You already know how to install and run Yosys by last 2 episodes. In today's episode, we will generate visual representation for GraphViz and NetlistSVG for post-synthesis, visual verification and debug. We will go through the dot file and JSON file generation used in the input of GraphViz and NetlistSVG web interface, respectively. These pictorial depictions of the synthesized netlist can further be used in your thesis or PowerPoint presentation for professional purpose. So, stay tuned, stay focused. Hey guys, welcome back. In today's episode, we will do graphical outputs. First one will be looking like this kind of output from the synthesis, that is our Yosys engine, and the second type of output will be this one. So this output will come from GraphViz, which we have already installed in the installation episode, and this kind of output will be coming from a JSON file output. What is a JSON? That is JavaScript object notation file. So this also can be generated from the Yosys interface. Today we will generate 2 different kind of graphical outputs and visualize them as graphics. So first we will generate a JSON file, and we will this particular website to generate a graphical output from the JSON code, and next to that we will use another way of graphical output for viewing with the GraphViz. Without any further delay, let us go to the command prompt. Here we are on our test case path. We are episode 7 here, GraphViz and NetlistSVG. So first, let me do a ls. So you can see the test case files are there, and let me launch the Yosys. So the Yosys prompt has opened, you can see, and now let me do the step-by-step the synthesis process that we have already done in our previous practical episodes. And once the synthesized netlist has been achieved, right, then we will proceed for the JSON file generation and the dot file generation that we will do with the GraphViz. So the first one we will go for the NetlistSVG, that is the JSON file, and the next we will go for the dot file, which we will view through the GraphViz. So the first command is here, read verilog, then we give the counter.b. First one is done. Next we do the hierarchy command. Next we will do the read library command. Next we will use the top level macro synth. So the basic synthesis macros have been performed and all the steps have been done. We have gone through the detail of these things in previous practical episodes. The next is the diff lead map command. We have executed that. Next is the abc command. Next we will go for the cleanup. And finally now we will write the synthesized netlist, that is write verilog synth.v. Up to this, we have done the whole thing in a fast forward manner, and we have reached where the synthesized netlist has been achieved. Now, next, what we will do? We will generate the JSON file, but before that, we will type here the help, then we give we space and we write the write JSON. So the write JSON is the command with which we will generate the JSON file. So here you can see it has given the details here of the JSON file that we will be generating. So let us have a quick look what are there. You can see it writes a JSON netlist, and if I scroll down, right, so what are the sections of this JSON, right? As per our Yosys, right, the JSON can have a generic format, but for Yosys we have a format, and that we can see with this particular help command. Now you can see there will be a module, then module name, then there will be ports, then there will be cells, net names, models, etc. So this will be completing one block. In the next block, when we scroll it down, right, what else will be there? So there will be a direction thing, input, output, in, out, okay, and the bits vector. And if you further go down, right, you can see here the cell details will be like that. So hide name, Okay, then parameters, then attribute, port direction, then connection. So all this will be present for a particular cell. Cell means a standard cell that we are using from the library for the synthesis purpose. And the next we will have the interconnect nets, right? So net details will be there. So there will be hide name or not. So there will be 1 or 0. This is a flash, and there will be bits. There will be how many bits the nets will carry. Like here you can see that this is a particular Verilog code, right? This one will be translated to the JSON output. Let me clear it out. This particular Verilog code translate into the following JSON output. Here one particular short example is there. You can have a quick look here in the terminal, right? So module, then test, then ports, then X and then Y. So you can see there are input X and Y port, and there are cells, right? So here you can see there are several cells here, right? You can see cells inst is there, and attributes is there, connections is there. And here going further down, you can find the net names. Here the details are there. So I think this will be sufficient for you to understand the JSON file. You can read in detail, read this particular help command, help then write JSON. Don't worry, all these things will be given in the description, right? From there you can copy it and directly paste in the Yosys terminal. So now we will write the actual JSON file in this particular command, right? So the command is write JSON followed by synth.json. That means synthesized netlist name is synth.v. According to that, the output JSON file, we are also naming it as synth.json. So here we hit enter. Here the file has been generated. You can see here executing JSON backend. So JSON file already has been generated. Here we cannot access it. So let me open a terminal. Same terminal in the right hand side. Here we do a ls -lrt. Here you can see our synth.v and the synth.json there. So JSON we have just generated. Here we open the JSON file with gbin. So here you can see all the details are there. Here modules is buff, then it has ports, and then A and Y. Buff is buffer, right? Then we have cells, right? Net names, then Y, right? And next we have DFF, that is the D flip-flop, right? So all the details of this DFF are there, right? So this way, enter JSON file will contain details about the design, all inclusive, that is the nets and the cells. So let me copy the entire data. Let me go to edit, then select all, then edit, then copy. So I have copied the entire JSON data, and let me open the browser. We will go to this particular site where we will generate the NetlistSVG. Don't worry, this particular website I will provide in the description. From there you can directly go. So here let me delete whatever data is there. So it's blank now. So let me paste the data. I have used Ctrl V here to paste the data. You can see that it contains the same thing as our EVIM, right? Let me show you side by side. So here I have copied this particular data here in this particular web interface shell is there. So I have copied this particular data and pasted into this particular shell. And now let me close the JSON file. And here you can see the option select skin. Either it is default means it's digital, and analog. So we are not using analog, we are using the default, that means the digital thing. And we will click on render. So once we click render, right, you can see here the entire netlist has been converted into a graphical output, and this JSON code which we have generated using the write JSON command, that has generated this particular output. So with this particular website, we can convert the JSON file into this graphical output. So this is called NetlistSVG. Now why it is called SVG? Because we can save it. Save image as, and once you try to save it, it will save as SVG. So let me go to the Yosys. We are on episode 7. So let me here type the name JSON output.svg. We will save this SVG file here. This is basically an image that you can use in any of your documentation. Maybe you are doing a thesis, right? Or maybe preparing some doc file or PDF, right? So there you can use this particular SVG file to represent the circuit which have been synthesized. So this will give you netlist, that means the circuit format. This is one thing. So next we'll go through the terminal. Next, we will go through the help of the GraphViz generation command. That is the show command. We'll type here help show. We will go through this particular show command. You can see here, and we will use a couple of switches like this prefix, then no title, then colors is right, this colors, okay, wait, and yes, this format. So this particular command will create a dot file. Now what is a dot file? Let me go back to this particular page. Here you can see one particular graphical output. So this is different from the netlist, what we have generated through the JSON. This is in the dot format, and this will be opened by the GraphViz software that we have already installed in the installation episode. So we will generate the basic files for this particular GraphViz format. Let me come back to the terminal, and here goes the command. So here we have used the prefix command. Prefix is nothing but whatever name it will contain, right? No title, then colors we have used, then weight, then format is dot. Dot is for the GraphViz format. So let me generate it. So here you can see synth file. This has been generated. Let me go back to this terminal. Let me again execute ls-lrt. So here you can see after the JSON, the dot file is generated. And to open this particular dot, we will use the x.binary, which we have installed during the installation of the GraphViz. So the binary is x. Then we give the synth.dot file. Dot is a format, and we give a %, at the last, and we hit enter. So you can see the dot viewer has been opened. So this dot viewer has been installed during the GraphViz installation that we have performed in the installation episode. And this entire netlist output is shown in the graphical format. So here you can see it's in graphical format. So there is a subtle difference that is in the netlist, that is almost in a digital circuit format, but this is a graph format. This actually contains the arrows and all, but every detail is there. So this you can also use for any kind of demonstration or inclusion in your maybe thesis or maybe any doc file that you are preparing, or maybe in presentation. So there is one subtle difference. You can see it's not in straight lines. So the JSON output was like this. The NetlistSVG, which have converted the JSON into this. So it looks more like a digital circuit, right? This is a different format. And then GraphViz. This GraphViz, the graph format is also another form of visualization in terms of network graphs. So these two are the outputs, the visual outputs that you can have after you have performed the synthesis. That means this is the graphical format of the synthesized netlist. The two things you can get as an output. Now, these are very important because not only in the documentation, but also if you want to debug your circuit and you debug anything inside the circuit, these graphs will help you. What connection is going where? So these things you can graphically see and graphically explore and debug. This is another helpful feature of these two kind of visual and graphical outputs. Let me see whether I can place them side by side. It's very difficult, but let me try it. It's me. Yeah. So you can see these two are. Let me zoom it in, and as we compare side by side, so this is the NetlistSVG format and this is the graphical output, that is the GraphViz format. So these two we have generated. So both of these will help you for graphical representation of the synthesized netlist as well as for your debug, and this may help in the documentation of your designs. So that's all, folks. We'll conclude our today's episode here. Thank you very much for watching up to this point, and don't forget to like, share and subscribe. In case you have some dislikes, put that as in words in the comment section down below, and bye for today.